Hello and welcome everyone. In this lecture, I'll be discussing about the concept of direct and reverse crank. So basically, in this concept is used in radial or V engines. All the connecting rods are connected to common crank, and this crank revolves in one plane. There is no primary or secondary couple, only primary and secondary force required to be balanced because all the engine cylinder are in same plane. The method of direct and reverse crank is used for balancing this specially radial and V engine. This method is very useful for determining the primary force and secondary force in radial or V engine. So let us discuss with this. Suppose this is the L length crank, omega angular speed, R is the radius, theta, this is the L length connecting rod, this is the R radius of the crank. Now the primary force, the unbalanced primary force will be equal to the Fp m omega square R, which will be acting like this. This is the length L, this is angle theta, so this will be Fp will be acting over here, m omega square R cos theta. So what will happen, this unbalanced primary force is equal to the horizontal component of the centrifugal force. This is our centrifugal force and it will be equal to this horizontal component. We having, this is our imaginary mass connected at the crank pin. Now the arrangement can be replaced with another arrangement that is shown over here. That above arrangement can be replaced if we divide the total m mass, we divide it in two parts, m by 2 and m by 2. So what will happen, here it will be the theta, here it will be the minus theta. The angular velocity of this will be in this direction and the angular velocity of rotation will be of this is in opposite direction. So what will happen over here, the cos component of both will remain the same, so ultimately the sum will be equal to this our primary unbalanced force. So by adding two mass we can balance our unbalanced primary force m omega square R cos theta, and there will be vertical component of sine which will be equal to m by 2 omega square R sin theta and m by 2 omega square R sin theta. So the above portion this portion is primary direct crank and this is our primary reverse crank. So this is used for the balancing purpose. Now the arrangement we have replaced, and this is our the O2C is O2C is our actual crank and this is O2C dash is our reverse crank. Now the primary or direct crank OC makes angle theta with the IDC position and rotating with omega in clockwise direction, whereas reverse crank is OC dash makes angle minus theta with IDC and rotating with the omega in anti-clockwise direction. So the primary reverse crank is the mirror image of the reverse crank is the mirror image of the primary direct crank. The angle, there will be only change of angle, that will be theta will be minus theta and this will be the angular velocity. Here it is clockwise direction and here it will be anti-clockwise direction. Now let mass m reciprocating part is divided into two parts, as we know that it is divided in two parts. One part is placed at the point C and another part is placed at the reverse crank C dash. Now the centrifugal force, we know that the at the point direct crank will be equal to m by 2 omega square r. So this is the, we discussed, this is the horizontal component m by 2. Same way for the reverse crank, it will be the m by 2, and the total component in the line of stroke will be equal to m omega square r cos theta, which will be equal to our unbalanced force. This total component of centrifugal force acting along the line of stroke, which is equal to the primary unbalanced force. So for determining the unbalanced primary force, m of reciprocating part can be divided in two parts, m by 2. So the centrifugal force will be placed at C and C dash normal to line of stroke are equal to m by 2 omega square r sin theta, but in opposite direction, and the component are balanced. So there will be no other unbalanced effect. So the unbalanced primary force due to reciprocating mass can be determined by placing masses m by 2 on each at crank pin, and primary direct crank and primary reverse crank at C dash. Same way, the unbalanced secondary force is given by the m omega square r cos 2 theta by n, and we know that it can be rewritten as, instead of omega we can write 2 omega square, and here instead of r by v, which will be equal to the equivalent crank radius r by 4n. So the concept of determining the unbalanced primary force can be extended to determine the unbalanced secondary force. Here this will be the secondary direct and reverse crank. There will be the same concept. We put here m by 2 and m by 2. This is our the secondary direct crank, and this is our secondary reverse crank. The angle will be 2 theta, and over here it will be minus 2 theta. This will rotate in clockwise direction, and this will be rotating in anti-clockwise direction. The crank radius will be the r by 4n, r by 4n, which will be the same. So what will happen if we take the horizontal component of this will be equal to the m by 2 omega square r by 4n cos 2 theta, and we take the horizontal component of this will be equal to the same. So we will get the secondary unbalanced force, and the horizontal acting force will be in opposite direction. So they will be automatically balanced. So this is the secondary and reverse crank. So the unbalanced force due to reciprocating mass can be divided in two parts. So this is the difference between the secondary direct crank and reverse crank. Now we can learn this from an example. Suppose there is an V engine cylinder center line set at 90 degree. The mass of reciprocating part is per cylinder is 2.5 kg. Length of crank is 100 mm and length of connecting rod is 400 mm. Now we have to determine the primary and secondary unbalanced force when the crank bisects the line of cylinder center line and engine runs at 1000 rpm. Over here m is given, r is given, l is given, and we can find capital N is given, so omega we can find. Now both engine are placed at 90 degree to each other. This is the 90 degree angle, so the half angle will be of 45 each. This is our line of stroke. This is the connecting rod for both, and this is our common crank. This is now concept of direct and reverse crank. As we know that there will be only change in the angle. If the direct crank, there will be the positive theta, and in reverse crank there will be negative. Same way for secondary crank, one will be positive, second will be negative. So or same, so we are measuring it in a way that for second it will be of 315 degree. So if we measure from this reference plane, so this will be just theta, and the second angle will be like this. This will be the theta 2 and this will be the theta 1. But for a reverse crank it will be negative. Same way for secondary, 45 means 90, 315 means 630. So same way we can find the secondary crank position angle. Now as we know that the primary force both acting at first, this is the line of stroke, first one theta 1 is 45 degree, so this will be one will be acting in this direction m by 2, and another angle over here for line of stroke of second cylinder angle is 315. So both masses will come in this direction for direct crank position. But and for reverse crank position, the one will be in, this is our line of stroke, we go in negative direction, so this will be the m by 2. This is the line of stroke, we will go in the negative direction, so this will be the m by 2 mass. Now this is the description for the same. For cylinder 1, theta will be plus or minus 45, and rotate crank 1 in clockwise direction from 45, and its line of stroke for direct crank position, and rotate the crank 1 in anti-clockwise direction for second reverse crank. For cylinder 2 we will do the same with angle 350, and it is seen that the reverse crank position system is balanced, and unbalanced force is only due to the direct crank. As we can see, the reverse crank is in balanced condition, but there is a force acting due to the direct crank. So what will happen, the unbalanced force will be equal to the sum of that m1 by plus m2 by 2. Both masses are same, m by 2, so that will be fp will be equal to m by 2 plus m by 2 omega square r. Same way for the secondary force, the cylinders are at 90 degree and rotate in clockwise direction. As we can see over here, the direct crank, the angle is positive, so this will be in this direction. So what will happen, and the secondary crank, the angle is of 630, so this will be over here. So the line of stroke will be in that direction. Same way for reverse crank, what will happen, we will go in the negative direction, so this will be the prior for cylinder 1 m by 2, and for over here negative direction 630, which means in over here, this will be the half for cylinder 2 and this half mass for cylinder 1. Now we know that this is the horizontal component and this will be the vertical component for angle 45. Now this will be remain unresolved, and this will be, because they are acting in opposite direction, so they will be same. Same way over here there will be unbalanced over one direction, and these two forces will be in a balanced condition. So the component of unbalanced secondary force due to direct crank will be equal to the 2 times m by 2 cos 45 into 2 times omega square r by 4n. The component of unbalanced secondary due to direct crank along the horizontal direction will be in the balanced condition. And same way for the reverse crank, we can find the secondary reverse crank force, and the total unbalanced force that will be equal to the force due to direct crank minus force due to reverse crank. So that will be equal to 0. So there is no secondary unbalanced force acting on the engine. So total unbalanced force will be equal to the only primary force, because the secondary force is equal to 0. So total unbalanced force is only because of the primary force. Thank you very much for watching.